Okay, we're getting ready. It is 12 o'clock. Or that we are streaming. In live. Okay. All right, so I say we get this program rolling. Welcome to Tuesday. This is Technical Tuesday. We are nothing but, I don't know about you, but I am just full of conference call after conference call after conference call, meeting after meeting after meeting. So, and I got one right after I get done with you today. So thanks for joining in. Appreciate that. Today, we were going to talk a little bit about the original title that I had for this was OEM Solutions and Options. But I realized that it's not just about the OEM. Its solutions and options are important to each of our businesses. Providing your customer with options and for different types of scenarios is just a important aspect of running your own business. And when it comes to the National Electrical Code, it's even more critical, and other codes and standards, because the NEC is adopted into law, and you have to make sure you remember that if you're not meeting the National Electrical Code requirements, it's not like you can just ignore those. In some cases, you're really going to, in most cases, and you may be able to come up with alternative methods, and that's what this is all about. You know, how do we avoid that red tag? Hey, Nihad, good to see you, buddy. How do you avoid the red tag, and how do we maybe put ourselves into a code plus environment, right? So I took, and as you can see up in the title, I struck out that word OEM because I think it does apply to OEMs, industrial control panel manufacturers, elevator control panel manufacturers, others like that. But in general, your business, whether you are a manufacturer, even if you're an electrician, if you are contracting firm, regardless what your operations are, providing solutions and options for your customers will help you meet that bottom line, help you get yourself out of possible issues. So, talk about industry news first before we get into this. And Nihad El Sharif is on the line with us. Remember that the Electrical Safety Workshop registration is still open, and I believe that the Electrical Safety Workshop starts next week. If I go to electricalsafetyworkshop.com, you got to spell it right. Don't put an I in the very beginning. If you go to electricalsafetyworkshop.com, it tells you March 9th through 11th. That is next week, but you can still register. So don't forget, go out to electricalsafetyworkshop.com. I also have a short video, relatively short video, that goes over all of the things the presentations that are going to be made there. Great opportunities. Felix Sandoval, you're the man. Good to see you. Good to see you online, buddy. So Factory Floor Friday, we had I don't know about you, but you can track Factory Floor Friday. Now, I can give you some advice. When I go online through my web browser, I can't figure out how to follow a hashtag. You might be able to do that. But I did notice there was a new hashtag that somebody had told me about, this keyword. It wasn't Factory Floor Friday, it was something else, because I'm already following that. I was on my cell phone. I typed into the LinkedIn, up in the corner of LinkedIn, the search. I typed in the pound, whatever it was. and it gave me the option to follow it. So I can get it to happen on my phone. I just can't get it to happen on my computer. So, but in any case, check it out. Don't forget to pound Factory Floor Friday. The Switch Boys did a great job providing you some of the ideas that they're bringing to the market, as did Matt Hussey from our Motor Control Center. He was talking about connected motor control centers. You know, remote communications plays an important part from a safety perspective. Getting your electrical worker out from in front of any piece of equipment, sitting in front of a computer remotely, that makes a world of difference. If the more we can do remote, remember what I said, promote remote, and communications and software is a way to get that done. And Matt was showing you some technologies that they're putting in our motor control centers going out the door. So you're going to want to check in on Factory Floor Friday on LinkedIn. Please do that. Single phase testing, IEEE 1584, we're going to be doing single phase testing down at our Busman facility for that committee. Dr. Lee will be either dialing in remote or showing up in St. Louis to help work through establishing the floor. One of the goals we have to continue our journey in IEEE 1584 is to establish that lower value of when you don't have to do an arc flash study. When will it self-extinguish? When will it not sustain itself? In 1584 itself, I believe, and I just opened this up because, yep, there it is. Section 4.3 of 1584 tells us for a three-phase system, sustainable arcs are possible, but less likely in three-phase systems operating at 240 volts nominal or less, with an available short circuit current less than 2,000 amps. So that helps us establish a floor for three-phase, but we don't have anything for single-phase, and we're going to be doing that. And what I think Dr. Lee is going to try to do is take some of that knowledge and help build the model for DC arc flash tests, DC arc flash calculations. So a lot going on from an incident energy perspective. The other thing I want to point out, there was looking for my little notepad. I had a new power systems engineer reach out to me today, Fidel Sangamba from out of Canada. I believe he's out of Canada. You can, if he's out there, you can let me know if I'm wrong, but I believe he's out of Canada. He's moving into a new role, power systems engineering, and he's looking for some information. And he and I had a great conversation on LinkedIn. But I told him I would let him know when I started in the power systems engineering world back in 1990, actually before 1990. When I was in school, I fell in love with power systems engineering because of an internship I had doing a short circuit and coordination study. This was the book. It's a yellow book. It's the buff book. Very important. IEEE Standard 242, this is 1986, and this is what they called the Red Book. Now, both of these books are being, there's the 3000 dot standards, so I'll try to put some links to that in my LinkedIn, and there are other reference documents as well, but those two are critical references that I know I used to understand power systems analysis. So IEEE 242 and 141, but again, those are being rewritten, and I'll try to put those links to those IEEE standards in there. And I know Nihad's out there, so he might chime in with that as well. Hey, we got Ryan Jackson in the house. We got YouTube. I got my tubers out there, my LinkedIn folks. So thanks for joining, Ryan Jackson. All right. So remember, I mentioned YouTube. Ryan Jackson and crew, they're out looking at my YouTube channel as well. We get some great discussion in this area. Remember, go out and visit, subscribe, hit the bell, all that great stuff, because I'm trying to put more and more materials out there. And I'll tell you, I go live every Thursday. Every Thursday I go live. And what we did last Thursday, just to give you all an update, we looked at a single line diagram that I prepared that is a real world application, I guess you would call it. I sort of made up some links, but I mean, we had a motor in there. We have 4160 to 480 transformer, 480 to 208. And we did a manual calculation of available fault current. And we did 2 sessions on that to help. What I try to do is do the calculation and then revisit it and highlight any of the items and issues and questions that we might have. And now last week, what we did was we were going through a process of selecting the overcurrent protective devices, meeting National Electrical Code requirements, all this good stuff. Now, what we did was we picked the devices for the primary and secondary of the transformer. And if anybody's following this, what you'll recognize is that we picked our primary overcurrent protective device of each of those transformers based upon the inrush currents, based upon the multiplying factors in the National Electrical Code. But what we didn't do yet is make sure that we're protecting that primary conductor. Because when we did our initial short circuit study calculations, I picked the conductor on the primary of that transformer based upon the full load amps. That's not the right way to do it. Other IEEE series. But I'll talk about that. But what we're going to do this Thursday at 5 o'clock p.m. Eastern is we're going to continue this journey of selecting the overcurrent protective devices, but we're going to start looking at 2 things. One, make sure we are protecting the conductor, so we'll probably have a discussion about conductor ampacity. I can anticipate that. And I would like to explore a little bit more of using fuses and circuit breakers. I want to talk a little bit more about selective coordination and incident energy reduction. And we're going to run some incident and energy analyses, whatever plural is for that. So we're going to continue that discussion on Thursday. But the other thing I want to get you prepped for is some homework is to take the impedance diagram from our initial study and create the impedance diagram for a ground fault current calculation. Now, to get that done, you're going to have to understand a little bit about positive, negative, and zero sequence currents. We're going to get knee-deep technical, but after we get through selecting and explore the overcurrent protective devices, the next step in our journey is going to be to redo that impedance diagram as a positive, negative, and zero sequence diagram to calculate the ground fault currents at buses A and B. We won't put the motor in initially because I want to get the fundamentals down of how you create the positive, negative, and zero sequence impedance diagrams. That is going to be fun. Juan Carlos, thanks for joining us. Exists another IEEE series for color books? Yes. So you know what, Juan? Let me try something here. IEEE, there's a whole series of books that they had, and again, they're in the process of redoing that book, that whole series. And there is a website. I'm going to put it in. I think I can put it in my comments here. Maybe I can, maybe I can't. I'm going to have to go to my LinkedIn site, and I will call up my LinkedIn live stream because for some reason, Restream will not let me post a message in my own stream. I am live right now. Paul Kaiser, I am live. Yes, join me, buddy. Hold on, LinkedIn. Believe I'm live. Gotta find my live stream here. There I am. All right. So I'm gonna mute this when it pops up so you don't get it. Okay, I'm gonna put a link in here to the IEEE 3000 series, and I'm going to also do that on my Restream. Control V. So everybody can have that. So I put it up there on my LinkedIn, and I put it out there for my fellows up there in on YouTube land and Facebook land. So you should have the link as well. But there is a bring it over here. This is the link I just put out there is for this the IEEE 3000 standards collection. There's a nice little video that they put on 3001.2 recommended practice for evaluating electrical service requirements, recommended practice for estimating. What they're doing is they're taking these color books series, and there was a brown book, an emerald book, a green book for grounding. The brown book was systems analysis. The emerald book was on power quality. The green book was on grounding and bonding. There was a blue book, and I think that was on circuit breakers. The orange book was healthcare, I think, or reliable power systems. So there was a whole color book series. I personally loved the color book series, and you could probably still find them and still buy them. But I liked, like, this one's the 1986 version of the Buff book. There were some really good examples. You'll notice, I mean, it's heavily used and abused, but great references for power systems analysis. And I cut my teeth on this. I learned how to do short circuit coordination studies out of these reference books. The Beeman Handbook. The Beeman Handbook, that's over there. The Westinghouse T&D book, another great reference for you. So please, yes, there's a lot of different references out there, and I'm showing you some of them right here. So, all right, so that covers that, and I put a link for that out there for you. All right, so hopefully Paul was able to join me out there on LinkedIn. We got James Smith. There you go, brother. All right, so don't forget, check out that my YouTube channel. We're going to be doing some heavy engineering, power systems engineering. I'm loving digging out. In fact, I woke up the other day trying to remember. I'm thinking, do I even remember how to do an impedance diagram for ground fault currents? So I was Sunday morning, I think it was. I come down here real quick, and I opened up SKM, and I did it by hand. I did my ground fault calculation by hand on a little power system example, and then I ran it in SKM, and they were exactly the same. So we're going to have a great discussion when we get to that. But your homework is to create that impedance diagram, and you can email it to me. And if you're following me on LinkedIn or Facebook or on YouTube, you can send me information. I would love to hear from you. I have a goal to get to 15,000 subscribers this year. I'm well on our way, but my goal on my YouTube site and my LinkedIn and whatnot is 15,000. So I'm looking forward to growing that channel, providing good, valuable information for you guys and gals out there who are studying to be for your PE exam, your EITs, or if you're just into trying to learn more about power systems engineering. I love it. So it's like a fuse. You know what I say about fuses? You know what they eat for breakfast, lunch, and dinner every day when they don't gain weight? Current. The more of it, the more they love it. So I'm like that with power system stuff. And looking for challenges. So ask questions, send me emails. You got a project you're working on, get me involved, because what I typically will do is get you connected with a field sales and our field application engineers. Those guys have probably forgotten more about power systems engineering than I can remember. And I just, again, I saw Paul Kaiser. He's one of our application engineers, and hopefully, he's probably out there. So I'll connect you up with all the right people. Now, I want to talk about the value options. So remember my discussion today, I wanted it to be around OEMs and providing options as an OEM, whether you made industrial control panels or elevator control panels and all this other great stuff. But I realized that it's not just the OEM. We do this all. I mean, think about it. Take a look at a restaurant, okay? A restaurant. Joe Bellantoni, but thanks for joining in, buddy. How many followers are we? I'd have to do the math now, Felix. I'll let you know on what we're up to now. But gotta get them guys out there visiting. But just think, if you owned a restaurant, if you focused in on one type of meal or one type of category. See, you were an Italian restaurant. If somebody was in the mood for good German food or a good hamburger, they're not going to come to your restaurant. Providing options will get you to a wider audience. Or providing options, if you have a customer that comes into your restaurant and says they're allergic to pasta, you've got to have options so that you don't get them walking back out that door. So our discussion today is just in general. Options are important for business, for sales, to get you out of a problem. Installation, so I categorize this into 3 areas: installation, worker safety, and maintenance. So let's talk about installation first. In this area, we're talking, I'm going to reference equipment ratings, reliability, and personnel safety. Now, the National Electrical Code made some changes and did some requirements in and around short circuit current ratings, interrupting ratings, and they're continuing that journey. Why are short circuit current ratings important, or an important part of the puzzle? These are tests that we've done in the lab, where we take a piece of equipment that's rated for 5,000 amp short circuit current rating, and we hit it with more current. These tests are fun because you get to let the smoke out. Okay, that's the important part. This is what happens when you exceed the short circuit current rating of a piece of equipment. So this is a, let's go back and just look at this video real quick. Hopefully I'm getting sound on my computer. No, that's my music. How do I get this thing to play? Here we go. So that looks like my shirt after Thanksgiving dinner, right? So what we did there was the components inside could not stand the amount of fault current flowing through that equipment. That is a short circuit current rating. A short circuit current rating is not trying to stop the flow of current. You'll notice that the problem that we created in this is not in the equipment. It's down here. We basically created a bolted fault downstream of this equipment that the equipment was not rated for. It's rated for 5,000 amps. We put 65,000 amps through it. This starter is not rated for the amount of current that we're passing through it. So what happens is that rate of change of that short circuit current puts a lot of pressure on the equipment itself, and it can't hold it together. So what's important to understand is that the National Electrical Code made some recent requirements to spell this recipe out. You need to know what the equipment is rated for. You need to know what your available fault currents are. And then you need to make sure that the short circuit current rating of your equipment is greater than the available fault current. Now, in my article that is associated with this Tech Tuesday, whatever you want to call it, I put all of the section numbers that are associated with each of these. Equipment ratings, it's marking of SCCR on equipment. That's mandatory. And a lot of times, if you're listing the product to a standard, you're going to cover that already. 409 is your industrial control panels. Tells you need to have an industrial control panel that is marked with the short circuit current rating on the equipment. Motor controllers, motor control centers, air conditioning and refrigeration equipment. This all talks about rating. And this is where the OEM, the manufacturer, comes into play. Think about a circuit breaker. Circuit breakers interrupt various levels of fault current depending upon the voltage, right? Not one circuit breaker can interrupt all fault currents. What do we sell? We sell a 10K breaker. We sell 22K breakers. We sell 42K breakers. We sell 65K breakers, 100K circuit breakers. So we have options for customers that they can select the circuit breaker with the interrupting rating that meets their needs. If they only have 4,000 amps available fault current, they don't need a 65K circuit breaker. You're going to pay more for a 65K circuit breaker than you will a 10K circuit breaker. So we're providing options. The circuit breaker world, and you look at our panel boards and switchboards, you'll see various options available for electricians, electrical contractors, design engineers. It's very important to provide options. That industry, from breakers and panel boards and switchboards, they've been doing that for years. Here's where things become a little bit newer for other equipment manufacturers. HVAC is doing a pretty good job of providing options for higher than 10K. I would say the low-hanging fruit for opportunity to provide options is, in my opinion, coming out of the elevator control panel world. Your elevator manufacturers have control panels. Unfortunately, many of those are only listed and rated. I don't know of any that are rated for greater than 10,000 amp short circuit current rating. And here's where the problem lies. We have the National Electrical Code making changes in these areas. They're raising the awareness. They're saying, look, you need to mark the equipment rating. You need to mark the available fault current for example, elevator control panels. There's a requirement now in the 2020 code. I'd have to double check. I think it was the 2020 code. That's the code that I took all of this out of. There's a marking requirement for available fault current on the elevator control panels, and that would be found in Article 620, Section 620.51D2. That requires you to mark the available fault current on the elevator control panel. It requires you to mark the SCCR on that equipment, and then this down here, doing that evaluation, who's going to do that? The electrical inspector, the consulting engineer who's aware of the changes. He's going to be going, well, these are the calls I get. Pittsburgh, Seattle, Washington, downtown New York. What do? Have a lot of fault current, and these are what we call secondary distributions, grid networked, where you have networked transformers in downtown areas. The available fault current at the bottom of those buildings is well over 100,000 amps. I remember talking to a chief electrical inspector in New York City, and I asked him, this was a while ago, he's retired now. I asked him, I said, what's the most fault current that you have in New York City at the bottom of these buildings? And he said 200,000 amps. And he says, do you know why we have 200,000 amps? And I was like, well, I was getting, there's paralleling transformers and there's all this other good stuff. And he goes, no, Tom, because you don't make equipment greater than 200,000 amps. The challenge is there's a lot of fault current at the bottom of those buildings. And then what do we use to get power up a high-rise building? Tim Cernko, he's retired too now, but he taught me that busway is called a high-efficiency fault deliverable system because it's got a lower impedance. You put busway in at these tall buildings from bottom to top. The available fault current at the top of that building is not knocked down because of the length of the conductors and the impedance, because busway is, it's substantial and it saves you a lot of money. There's a lot of great reasons to use busway. The challenge is the fault current at the top of that building is not knocked down very far, and now you have an elevator control panel that's up at the top of that building, or HVAC equipment that's at the top of that building, and the fault currents are greater than 10,000 amps. And now what's happening in the code is a level of awareness for the rating of the equipment, the available fault current, and to make sure that your fault current is less than the rating of the equipment. It's important for safety. So that's all I have to say about that one. Promote remote, that's a slide from last time. So the message here, from an installation requirements perspective, there are code sections and code requirements that may get you into a challenge, a bind. 240.87 is another good one. A lot of people forget. 240.87 tells us that the circuit breakers 1200 amps and above have to have an arc reduction technology on them. So you're going to have to do an evaluation. If you did not know that, and you have a project with a 1200 amp breaker or larger on the project, and you've not looked at it, purchasing the equipment, getting it installed, you may find out that the circuit breaker that you selected needs to have an electronic trip unit, needs to have an arc reduction method employed, and you may not be able to get it done with the product that you purchased. So you got to be mindful. That's why it's really important to go through code change presentations and get engaged with the industry where we're doing code changes. I did a whole series on the 2020 National Electrical Code early last year. I'll probably do another refresher. We even had I called it Shock Week, and we talked about the requirements around shock hazards and things of that nature. So you're going to want to check check out, get an update, understand what version of the code your jurisdiction is in as well, because that's another very important piece of the pie. All right. So just looking to make sure I'm covering everything I wanted to cover with regard to this. All right. So make sure you have the equipment ratings. Make sure you understand the code changes that are out there. And from an installation perspective, think about working space. Think about working space for your electrical worker. Provide options, front access equipment. Can you use that instead of having rear access equipment? That might save you some room in these rooms. Remote capabilities, things of that nature that are things that you can only do during installation. That's the other thing to think about. And we're going to talk about the third area is maintenance, but from as we go through each of these three categories that I have, think about what are the specifications, what are the solutions that you can put on your next project that you're not going to do after the fact. I built my first house when I built it. I wasn't married at the time, so I didn't have to worry about what lighting I was going to have and the kitchen cabinets and whether or not the floor. I focused on the generator. I wanted heat in the cement in the basement floor. So I invested money in areas where I knew I wasn't going to do it later. But then I got married and sold the home. So whoever it was that bought that home is benefiting. So this house here has geothermal. When I moved into it, I didn't put geothermal systems on my other house. This one has a geothermal system, and I'm reaping the benefits of that. But it's not something that I would do after the fact. The same thing goes on our electrical distribution systems. There are value propositions. There are ideas and products and solutions that your customer's probably not going to bring to the table after the fact. Now is in the door, before you get into installation, before you even go out for quote, it's important that the customer, the end user, the architect, the home builder, whoever it is, whatever the project is closer that you can get to the owner, the more certain value propositions will resonate. So, and I have a little slide on that, which probably people will love to hate, but I'm going to talk about that one in any case. All right, so, whoops, I'm jumping around on you. I just want to make sure I got all the stuff I want to talk about. Personnel, shock, GFCI, AFCI, ground fault protection of equipment, working space, really important for the electrical worker. And it's not that you're going to buy a product from me. It's just you're going to provide enough working space in that equipment room for the electrical worker. Worker safety is my second category. Facilitate the electrically safe working condition. And it goes back to the earlier discussion from an installation perspective. You think about the phases of a project. If you know a piece of equipment is going to be worked on, likelihood, remember our discussion, likelihood and severity. If you know the likelihood of justified energized work being conducted on a piece of equipment, plan for it. Facilitate the electrically safe working condition. And in this article, under that category, let me just make sure I covered. Yeah, I put a link to last Tuesday's discussion, the article on the promote remote concept and all this other good stuff. These are all things that we can do to provide options for our customers. Don't just, I started a program at EATON called the EATON Certified Contractor Network. That idea came to me. I woke up one morning and that's when things come to me. And I said, you know what? I was frustrated at the time because I was product manager for arc fault circuit interrupters and ground fault circuit interrupters, those types of products that you would see in a residential home. And I came to a realization that our industry has two types of contractors. Now, I'm going to categorize And if you're an electrical contractor, think about this. Most contractors I talk to, this resonates with. Some contractors I've talked to said, "No, that's not right." But I'm going to tell you my philosophy or my perspective from being in that product line. I ran into two types of contractors. One contractor that loved to work with home builders. They wanted to do new construction. They wanted that bigger. They wanted that contract for 30,000 homes or whatever number of homes it was, and they knew that they were in, and they knew they knew the design of the home. They knew exactly. It was almost like cookie cutter. It was their whole goal was to just keep up with the builder. They never wanted to talk to the homeowner. They didn't want to talk to guys like me. Like when I built my home, I could not wait to talk to my electrician. I kept telling my builder, I want to see my electrician. My electrician finally scheduled something. We get to the house. I told him I want a generator. And he says, you don't need that. I want light switches here. I want 2 light switches there. I want these types of lights. They don't want to deal with that. They want to get in and out. They want to keep up with their builder. The other type of contractor that I've noticed is the one who loves to talk to the homeowner. They love to troubleshoot. They love to go in after the fact and say, I can add that 240-volt circuit to your garage, Tom, for your welder. I can do that for you. And here's how I would do it. And here's the price. Oh, you want to upgrade your service? I want to do that. You have a problem with a receptacle in your bedroom not working? I will love to troubleshoot that. Two different types of people. Okay. And so my frustration was to get that person who deals with existing homes to go into that home and talk to the homeowner and say, while I'm here, I offer a service. I'm going to test all your GFCI receptacles. And oh, by the way, when I walked through, I noticed you don't have GFCIs in your kitchen. There's no GFCI protection, that's required by code. May not have been required when you built this house, but here's the value and here's what it brings to the table. I used to tell the contractors, keep a surge product on the truck, keep GFCI receptacles, keep GFCI circuit breakers on the truck, use our classified breaker. We have classified AFCIs, classified GFCIs. What that means is I can put that in anybody's panel board that it's listed for, and it's got a whole laundry list. Have those options for your customers so that when you go in, if a customer hired you to add a motor, or a customer hired you to change a light out or put a ceiling fan in, if it's an industrial facility, your customer says, I'm hiring you to, I'm going to hire you to add a new motor or add a drive, variable frequency drive. Build that relationship. Talk to them about establishing the electrical safety work practice condition. Maybe there are options to put a disconnect in the circuit that you're working on. Help your customer understand, look, we can address the personal protective equipment. Your incident energy we're going to be doing this work. We may have to do energized work, but the PPE is so wild and crazy that we may want to get a shutdown. And you may want to, when you establish the electrically safe work condition in that area, you might want to consider adding some other solutions to reduce the incident energy. That's the key. We need to educate our owners. We need to educate those. They're focused. Think about it from a say you're I don't know, say you make automobiles and you make the best gosh darn automobiles in the industry. You're focused on making automobiles. Are you focused on the power distribution system? The only reason you're worried about your power distribution system is because you don't want any downtime. You may not be the expert in the power distribution system. You're going to hire somebody for that. You're going to have somebody on staff for that who's trained in that. And whether you're an electrical contractor, an electrical inspector, a manufacturer, a design engineer, our goal has to be to educate the owner and provide these options to them so they make educated decisions. If I can facilitate an electrically safe work condition, then that means I'm not working hot. That means the likelihood of sending somebody to the hospital or the likelihood of a court case or the likelihood of downtime in my facility is low. Okay? Much lower than it would be if I don't try to avoid energized work. And PPE, if I can reduce the severity by strategically putting in a fuse here and there, strategically putting in a circuit breaker with an arc reduction maintenance switch, or employing some arc quenching technologies in strategic areas of my facility. Just don't open the checkbook. I mean, I know my sales guys would love for you to open the checkbook and say, give me the best of whatever you got. No, you got to do things in a smart way. You got to strategically invest in your power distribution system, the right locations with the right tools. I love the fact that we offer fuses and circuit breakers. I love the fact that I can give you an AFCI or a GFCI circuit breaker or a wiring device. I can provide options. I can take the debate off the table and get you the right tool for the job. That's a great position to be in, but you need to think that way as well, especially if you're not a manufacturer, if you're a consultant. Understand your options. Understand you need to get that to your architect or whomever. All right, maintenance. Maintenance is very important, and I would argue a very critical part of the pie from an options perspective. You know, I put yourself. I don't care if you're a contractor, manufacturer, designer. You know, I once talked to an electrician. We had stickers as part of this ECCN program. We had stickers that they could put their name, their phone number, their address, and put it on the power distribution panel. And I know I leverage this. You know, now we have a maintenance plan for our HVAC system, but before that we had some problems, and it was a new home. I wasn't sure who had serviced the unit before. So what did I do? I walked down to my HVAC unit and I looked on it, and there was a sticker with a company's name and a phone number and a web address. I called them. They came out. They serviced my equipment. We built a relationship. They're working on it. They will continue to work on it. They didn't realize the house changed owners, all this other good stuff. So that goes a long way. That's a business lead waiting to happen, right? And it worked into a service. He sat down with me. He said, well, Mr. Dimitrovich, he says, you know, you have a geothermal system here. He says, we offer this plan. If you get into this plan, I will come out once a year, twice a year, once in the spring, once in the fall, get you ready for winter, get you ready for summer. And if there's anything broken, we give a percentage discount off of your parts. Beautiful. I said, where do I sign? The price was reasonable. And it's an annual basis. That organization is performing maintenance on my HVAC system. Your power distribution system is very similar, whether it's making sure the GFCIs are working, your AFCIs are working, your industrial control panels are cleaned, your motor control centers are cleaned. Preventive plans are important. And as part of the installation, we just came out with a line of circuit breakers that'll give you the health of the circuit breaker, right? This is going to help in your maintenance plan, your preventative maintenance. If you can go to your circuit breaker and say, what's the health of this device? I should be pulling maintenance on this one because it's seen a lot of activity. It's interrupted, not bolted fault currents, but a decent number of heavy currents. It might be a time to pull maintenance on it before you get a problem. You'll know what you need to get, so you swap it out. You reduce your downtimes. You increase your uptimes, your productivity times. You want to keep the plant running. You want to keep your house moving. You don't want to miss the ball game. So it's important to have a plan in place. It's important to work with the manufacturers to understand what are the plans, and can I get a product in certain areas of my facility that are maybe more harsh than others that will give me the indication on when I need to pull maintenance. So it's critical. And some of that, like, you know, if we have a whole circuit breaker line that has this health indication on it. If you didn't buy that and you needed it, well, you're going to have to change. You're going to have to change the breaker out to get it, or try to do the trip unit. But it's a multi-case circuit breaker, so I can't do much with regard to upgrading it in the field. So you got to think about these things ahead of time. It's really important. And you got to make sure you have qualified partners. Now, the safety ball. You know, I'm an electrical engineer, and I'm in sales, vice president of technical sales, until you ask me for a price, because it's technical sales. What do? I try to educate people technically. So this is a power systems engineer perspective on our markets. And I'm calling this the value ball, the safety value ball. And I'm specifically calling it a safety value ball. Because here's my perspective. And you may agree to disagree. You may laugh. But that's okay, because I'm going to get you thinking. In my perspective, the owner and marketing. So take a, I don't care what you are. I don't care if you're a manufacturer, you're an electrical contractor, if you're a big firm. You have the end user, which is the owner, and you have a marketing group. They typically are going to be in line with each other. From a safety perspective, we can talk arc flash safety. I can show you the statistics. I can show you how many people get hurt. I can send you out to DonniesAccident.com and you can listen to from an arc flash survivor. We can talk about the cost from an event. It resonates with the owner because they don't want to go through that. It resonates with marketing because it's an easy thing to visualize. I can wrap my head around safety topics. I can wrap my head around a seat belt. Hopefully, don't wrap my head around a seatbelt. I guess that's not a good analogy. I can understand seatbelts. I can understand airbags in vehicles. And as a vehicle owner, I understand. I click it. I don't click it because I'm going to get a ticket. I click it because it's the right thing to do. I feel secure in my automobile, and I'm happy that there's an airbag in front of me that could save my life one day if something would happen. I would want that on my vehicle. I would want seatbelts on my vehicle. If they said they're extra price, do you think I would put it in? I probably would. So the marketing team and the owner are, for the most part, I think they're in line with each other. But now the further you get away from the owner, you get to the architect. The architect, and I put him a little bit down on the value chain, because think about the architect. Think about the home builder. Replace the architect with a home builder. The home builder wants to talk about the sexy things like the chandelier, the granite tops, the hardwood floors, the French doors. You know, this is a more expensive French door. They want to. That's easy stuff because we can relate to it. The home, in a lot of cases, the architects knows a lot about the architect, but not a lot about the electrical system. So in many cases, the architect may not understand the hazards, and they're not going to necessarily deliver that value proposition to the owner. And then if the architect's not important, the consultant's not going to see it as important, because if the architect doesn't, if it doesn't resonate, if either they don't understand it, and they're not aware of it, or if they are aware of it, they may or may not bounce it off of the owner. So the value proposition of some of these safety aspects is a little bit lower from the architect's perspective. And if it's lower from that, then the consultant's going to be like, hey, I'm not going to throw safety in here because it's just going to get pushed back. It's going to make me look inflated. The architect and the owner's not asking for it. And then you get the sales guy who's got to quote the order. They're not going to sit down and say, hey, you know what? I'm going to do this new selectively coordinated thing, and I'm going to provide you with a reliable power distribution system. It's going to be more expensive, and I'll probably lose the order. No, they're not going to do that. They want to get the order. They want to make sure they meet the consultant's needs, and who's trying to meet the architect's needs, who's really trying to meet the owner's needs. But we lose the message of safety. Now, then you move into your organization. Your engineering teams, they get it. But they're close to the sales folks who say, I love the concept, but I can't sell it because my consultant's not going to accept it. Then you have the product line marketing, who's the product manager, is going, wow, you know what? If I add these technologies in there, I'm going to provide this value. It's probably something that will save the owner money. There's value there. And then you work your way back up to marketing. So I think the key to this is to connect with the owner. Because if the owner says, I want that, I want that shock protection. I don't want downtime. I want power system reliability is important to me. If you get that owner educated so that they ask for it, that is utopia. And I believe there's a lot of value in reducing downtime. If you're in the petrochem industry, I think gets it. I know for a fact, in a lot of cases, they get it because they're specifying stuff. They were using zone selective interlocking before 24087. They were using arc quenching technologies. They're using arc resistant switchgear and things like that because they get the value of the safer solutions. Why? Unfortunately, probably off of experience. What happens? What happens to us? I mean, just personally, do you wear your seatbelt? The first time you had a fender bender or a friend of yours lost his life in a vehicle and they say he wasn't wearing a seatbelt, went through the windshield, you're going to think about that next time you get it because it's a personal experience. The more personal the experience, the more religion you get, right? Donnie'saccident.com. Donnie's a big believer in electrical safety, but before his event, he wasn't. And he'll tell you that. He'd sit in a training presentation, put his feet up and not pay attention. Why? Because in his eyes, it was the owner of the company just trying to cover his butt with regard to legal issues. So I think it's important for us to understand that we need to get to that owner because once you do, you level out the playing field. The architect gets the safety proposition. They're going to deliver that to the consultant. The consultant gets it, delivers that to the sales engineers and who are working up the projects, and everything comes in line. Value of safety is there for all players involved. So my thought process is, how do we get to the owners? How do we get the architects closer to the owners? And I think it's through education. Summary. Robert from Omaha, one needs to be educated and to educate customers, workers, etc. I agree. Thanks, Robert. And that's why I'm doing these programs, because I firmly believe the more educated our buyers are, the more educated the homeowners, the end users are on the value propositions of electricity is not a set it and forget it thing. Unfortunately, electricity in a power distribution system doesn't get attention because it's just a means to the end. Why is electricity important for Ford Automotive or GM, General Motors? It's not because they sell electricity, it's because they sell cars. They sell trucks, and they make money off of cars, and they make money off of trucks. So they need the power up. It's a necessary evil. If they could get it done without electricity, you think they would? They probably would. They wouldn't have to have an electric bill. It's probably pretty huge for a company like Ford or GM. If they could get away with not using electricity, then they probably would, but they have to have it. So our job as electrical industry, as electrical professionals, is to make sure that what we design, what we lay out is safe, and we get our customers asking for it. We want them, because we can't rely on codes and standards. I do not want to rely on codes and standards with regard to electrical safety. I would rather live in a code plus world where the owners and the designers make the decisions for a safer solution. Codes and standards is a bare minimum requirement. We should be going above and beyond anyway. So from my summary perspective, educate yourself. That's the first thing. And to Robert, your point is exactly right. We need to educate ourselves on what the solutions are, because you don't know what you don't know. Did you know that EATON offers health indication on our circuit breakers? You may not have known that. Now you do. Now you know when you go down to your sales office, you need to ask them. Or if you're a Square D customer, if you're a GE customer, or an ABB customer, ask them, do you have health on your breakers? I want to know what the health of this breaker is. I want to know what the condition of that breaker, what it saw from a history perspective. I want to know the environment that my electrical product is, because I rely on that product to reduce my incident energy. I rely on that product to establish an electrically safe working condition. You need to understand your customer. And if you're a plant manager in a facility, your customer is the manufacturing floor. Your customer is product engineering management. Your customer, we all have a customer, regardless of where we're at. You could be pushing a broom. You have a customer. You know how to understand your customer's wants and needs to succeed at what you're doing. Understand, know who your customer is, arm yourself with an education, and understand the pluses and minuses. What makes your customer tick? What is of value? Because that's going to help you identify the value to that. And your customer could be an application, right? And then understand that application. So I can almost say your customer could be, if you are the person managing a production line, your customer is that production line. You know that every part and piece of that production line has to be working. You know what keeps it working well. You know what will stop that production line. So you will have a better understanding of the value proposition, so that when you educate yourself on the solutions, you'll know what will fit. Don't just buy something to buy something because, hey, it's got the buzzword associated with it. It's got to fill a need. It's got to produce something for you. It's got to help your bottom line. And then you need to educate your customer. The more we can educate our customer, the better off we are. We've educated ourselves. We understand the customer and the application. And then we can have a sit down with the customer to say, look, downtime is expensive for you. I know based upon research, it costs you so many millions of dollars a day, or so many millions of dollars an hour, or possibly a minute of downtime. I can help you avoid downtime with these options. So providing options for your customer is critical, especially if there's a problem, there's a code issue, if there's a violation, a code violation. If you don't have a solution that at least meet the National Electrical Code and an effective way to swap out a product or provide a solution that'll meet that code requirement, that's a problem, right? We are here to provide solutions. We don't want to hold up a project. We don't want our customers to experience any ill effects from code requirements or incident energy or shock or any of the hazards. So that's my summary. I created a little document that I'm sharing as part of the link down below on my LinkedIn site. I'll have to. Oh, actually, it's probably on my YouTube site too. This little tool I think updates all 3 platforms for me. So I have not been watching any comments or whatnot, but cost can pile in. Yes. That's exactly right. Cost is important. And Robert, that's why, in my opinion, you have to understand the value you bring to the table. No matter what it is, if we bring a solution to the table, you have to understand, is it going to save your customer money? Is it going to save them aggravation? Whatever that value is, you need to bring that to the table. That's what's going to sell, even safety. Even safety. Statistics. That's why in last week's little 1-hour session, I think it was last week's 1-hour session, I talked about, you know what, Nihad, you're right. This could be a good IEEE paper. Bringing options to the table. That's a good point, Nihad. Nihad and I like to do papers together, and this might be another one. So check out my article, OEM solutions and options. Remember, it's not just OEMs, it's anybody. You need to have solutions, you need to have options. Even if you're going to go to dinner, you want options, right? You want to sit down at a restaurant that has options, not just one thing. Safe work practices. Remember 70E. Think about 70E from the perspective of 110.1 of 70E. Hazard elimination shall be the first priority. If we can focus on that, solutions, there are a lot of solutions that you can bring to the table. You need to bring that to the table. And then 70B maintenance, that's another little news item. I don't know if it's next week. No, it's week after next. Week after next begins first draft meetings for 70B for maintenance. Scott Brady and I represent EATON on 70B, and I'm chairing a task group right now, and we're talking circuit breaker maintenance, fusible switch maintenance, fuse maintenance, all these great things. So that document's going to have a lot to offer, in my opinion. My tool does not show up on YouTube. I'm going to have to check that, James. I'll take a look at that link. Justified, energized work. Yeah, you know, Robert and I talked about making some changes to 70E to highlight that terminology, justified, energized work. It's not just doing energized work. It's got to be justified, energized work. So, Robert, keep the faith, brother. I appreciate you, and I appreciate what you do for electrical safety. And you too, Nihad. I'm looking through. Kahili Baha, good afternoon. Good to see you online. Thanks for joining in. Felix Sandoval, God bless you, brother. You gotta let me know when you get that cup. And Juan Carlos. And you know what? Really excellent content, improved knowledge of electrical safety. You're welcome. And Kazi is your last name. I don't know your. I'm not even gonna try. I'm not gonna butcher it. I'm not gonna do that to you, brother. Ain't gonna happen. And we got Kevin Breen, first time live for me. Thanks for your info on YouTube. Thanks, excellent, Kevin. Thanks for joining. Appreciate everybody. And remember, we're gonna get to 15,000 subscribers. I think I'm somewhere around 5,000 or 6,000, somewhere in that right now. So we got to get those numbers up, for no other reason other than to just get the word out. Right. So I go live on Thursdays at 5:00 p.m. Eastern. And this Thursday, we're going to be talking about overcurrent protected devices. We're going to continue that exploration. And I think next Thursday, I'm not sure, I got to check. Remember, your homework is to take let's just do this real quick. Your homework is going to be, remember, we have on our program on Thursdays, let me go to, I go there, I go to Tech Thursday, and I go to Power Systems Engineering. We're going to continue our Power System Engineering discussion, and your homework is to do the following. Remember, this is our one-line diagram. I got a transformer. I got two transformers for this. And what we're going to do is, you'll notice that we picked the primary fuse. We picked the primary circuit breaker. But we're going to have to make adjustments to our conductors, increase the size of those conductors, which is going to do what? Probably increase our fault currents downstream. But we're going to show you that on the secondary of this transformer, not that much. And you should have already learned that from one of my earlier sessions. But here's your homework. Remember, we did this. We created the impedance diagram. This is our impedance diagram. And we're going to continue to use this model, even though we're making changes in our other example. But we're going to go back to this model because we've already calculated all of our per unit impedance values. You can start with this, and you need to figure out what is the impedance diagram to calculate the ground fault current at bus A and bus B. That is going to take you into a journey of understanding symmetrical components. The power system engineers out there who took those classes of symmetrical components, you know what I'm talking about. Positive sequence, negative sequence, and zero sequence. We can represent this single line diagram in all three of those sequence tools. You know, and that was what? CL Fortescue. Okay, we're going way back now. I want you to create the impedance diagram for calculating ground fault currents at bus A and bus B. Those are delta Y ground transformers. It's another very important piece of the puzzle. So don't forget that. I can't wait for that discussion. Alrighty, so I've already got that. You know where the YouTube channel is. Don't forget, get over there, take a look at it. If you like it, thumbs up. If you don't, smash it. I'm fine with it. Give me your feedback. I love to know. And I want to create a network of people working together. We as engineers should not live in a vacuum. We need to communicate with each other, and that will help grow our knowledge. Thanks for watching. Appreciate the feedback and the comments. This is like the KVA method. Yeah, Juan Carlos, you do your KVA method, see what numbers you come up with. What we do in my class on Thursday is we do a manual calculation, and then I compare it with SKM. I happen to have an SKM license, so I use their AFALT program, and we verify our numbers. I make some mistakes here and there. Granted, I'm forgetting the me and the square root of 3 don't get along. We never did, but we're getting closer together. We're making amends. We're talking. We're communicating. That's a very important part of that relationship. Me and the square root of 3, and then the decimal point. I don't like to work on the right side of the decimal point. I love to work on the left-hand side of the decimal point. Just ask my boss. But we're going to have fun. Do it in the KVA method. See if you get the same numbers, and bring that to the table, Juan. I want to see that this Thursday. Bring your numbers, and we'll compare. We'll do a comparison. So please look forward to seeing you on Thursdays at 5:00 p.m. and every Tuesday. Although next Tuesday I got to look. We are going to be in. Next Tuesday, we have electrical safety workshop next week. So I'm hoping we have lunch breaks that I'll be able to go live, and I'll give you an update on what's going on in the ESW. But hopefully you're going to be attending. All right. Thanks for watching. Thanks for doing what you do for electrical safety and the electrical industry. You know my contact information. Reach out to me, and let's learn some stuff together. Thanks again. Take care. Stay safe. And please, by all means, stay healthy. See ya. Till next week.